students, welcome back to my channel. Today I'm going to teach you squares and square roots of class 8. It is taken from the Ratna Sagar book, number magic book. It's followed by both CBSE and SEBA. Hope you all will enjoy. And one more thing I would like to say, that I'm very glad that you people are sharing my videos and liking also. So let's start our syllabus. Hello students, today I'm starting number magic book. It's written by Ratna Sagar. It is followed by both CBSE and SEBA. I'm doing the chapter squares and square root. So here is a chapter squares and square root. I'm starting from the exercise 11A. I'll be doing one sum from each. You try the left. Question number 1. Exercise 11A. Question number 1. By using prime factorization, check if the following numbers are perfect squares. So we need to find the factors, prime factors of the number 1, 9, 3, 6. Here you find 1, 9, 3, 6. As it is an even number, it will be divisible by 2. By 2 again. By 2, by 2 again, and 121 is 11 into 11. Therefore, 1936 can be written to 4 times, then 11 into 11. Now, when it is called a square number, if the factors are in a pair, then it's called a squared number. So these two are in a pair, these two are in a pair, these two are in a pair. Therefore, what we can say, as the numbers are in pair form, so it is a squared number. Clearly, the prime factors can be grouped into pairs of equal factors and no factor is left over. Therefore, 1936 is a perfect square. What does this sentence means? If other than this we have like in a number, if suppose it is the number where one more factor is left out, like 3. So what will happen? 3 will be left over without making a pair. Then it will not be a squared number. Suppose here if I take 12 is written as 12 can be written as 2 into 2 into 3. 2 and 2 can be written as a group, but 3 is left over. So 12 is not a perfect square. Okay. Question number 2. What is it said? Show that each of the following number is a perfect square. In each case, find the number whose square is that given number. Let's take one number, this one. Again the same procedure have to be followed. First, if it is a squared number, then only the other part can be done, otherwise not. As the unit digit is 5, so it will be divisible by 5. Therefore, 2025 can be written as a 5 into 5 into 3 into 3 into 3 into 3. So, as clearly the factors are, in short also you can write the prime factors can be written in a pair of same factors. Therefore, 2025 is a perfect square. Up till this much is similar to question number 1. Now the second part, as it is a perfect square, then of which number it will be the squared number. Like again this part you repeat, 2025, 5 into 5 into 3 into 3, 3 into 3. Now 5 square, 3 square into 3 square. So it will be 5 into 3 into 3 square. So 45 square. Therefore, this is the number whose square is, therefore the number whose square is 2025 is 45. This answer. Okay. Now it's question number 3. 1. Find the least number by which the given number should be multiplied to get the perfect square. And then find the number whose square is the resulting number, the same procedure. So it means what? Here will be left over some factors. Again the same process have to be done. You need to factorize 1, 4, 5, 8. Need to factorize 1, 4, 5, 8. Then by 9 to 11, 18, by 3 it will be divisible. 3 2s are 27, 9, 3, 3. Therefore, 1, 4, 5, 8 is equal to 2 into 3. How many times? 1, 2, 3, 4, 5, 6. Here is a pair, here is a pair, here is a pair. Just one number is left over. That means if somehow we can make it as a pair, then it will be a perfect square. So that means we need one more 2 to be multiplied. Therefore, you write, therefore, the number by which but the number by which it is to be multiplied to be multiplied to make a perfect square is 2. Does the number formed is equal to 2 into 2 into 3 into 3 into 3 into 3 into 3 into 3. Thus you do the same process what you have done in question number 2. 2 square, 3 square, 3 square, 3 square. Sorry, 1, 4, 5, 8 into 2. So 2 into 3 into 3 into 3, 54 square. So we'll write hence the number whose square is the new number is 54. Question number 4. Find the least number by which the given number should be divided. The same process what you have done in the question number 3. There we had multiply, here is to be divided. While dividing, the number will be removed. 2800, take out the factors. Therefore 2800 is equal to 2, 1, 2, 3, 4 4 into 7. Pair, this is left. Here one thing you can mention that it's not a, therefore it is not a perfect square. This also you write, therefore it is not a perfect square. Thus the number is to be divided. Number is to be divided to make it a perfect square is, which is the leftover number by that only to be divided, is 7. Thus what we get, 2800 will be divided by 7, this whole part. sorry, it is divided by 7. Those 7 got cancelled. Here left 2 square, 2 square, 5 square. 2 into 2 into 5 whole square, that is 20 square. Therefore, the number required number is, you can say required number is 20. Question number 5. Find the smallest square number that is divisible by each of the numbers 8, 9 and 10. So, smallest square number question number 5. Find the smallest square number that is divisible by each of the number 8, 9, 10. So, the number which is divisible by each of the number, smallest number, which is the number 8, 9, 10, will be their LCM. We'll write the smallest number which will be divisible by each of the number 8, 9 and 10 is their LCM. So, we need to find out the LCM of them first. 8, 9, 10. So, no more. Therefore, LCM 360. Now, what do you do? Factorize again. So, if you factorize this by 2, so we have seen 360 can be written 2 into 2. One more 2 is left out. Here 3 into 3 is in pair and then 5. So, this 2 at this 3 pairs we will write together and bringing this 2 on the other side. So, to make this as a perfect square, again by 2 and by 5 both to be multiplied. Therefore, in order to make it a perfect square, 360 is to be multiplied by 2 and 5 both, by 2 into 5. Thus, it form what? 360 into 2 into 5. So, 2 5s are 10, 360 into 10, that means 3600. This is the required number which will be divisible by each of the number. Therefore, the required number is 3600, which is divisible by each of the number 8, 9 and 10. Question number 6 is similar. Then I'm doing exercise 11B. Here the important sums I'll show you. All those are like perfect squares only. Here need to be find that sum, find that sum formula, square of a rational number, finding the product of two consecutive or odd or even numbers. So let's begin the question. I'm taking question number 5. Here it is given 39 square minus 38 square. What is said? Evaluate the following. If we need to use the formula, we could have done like a plus b whole a square minus b square formula. But here is another formula to be used. The formula is, if it is 38, then it will be 1 more than 38, 39. So if it is n, then other will be n plus 1, 1 more than n. Thus, when we open it up, n square plus 2n plus 1 minus n square, those are cancelled, so it remains as. So here let n is equal to 38, the smaller one you take. Then use this formula, n plus 1 square minus n square. So we can write twice n plus 1. This simplified form also can be written. Don't get replaced there the value. Then it is 38 plus 1. So plus 1, so it is 77. Here is the answer. Question number 6. Without adding, find the sum. Sum of the odd numbers. Here we also have some formula. When we find the odd numbers, sum of the odd numbers, then it will be how many numbers are added, the square of that number have to be taken. Like here we have 1 plus 3 plus 5 plus 7 plus 9 plus 11. It is the sum of how many terms are there? 1, 2, 3, 4, 5 and 6. So as it is a 6, so we'll write sum of first 6 odd numbers. That means 6 square. So it is 36. It's question number 1. So how many terms there would be that you make square? Question number 7. It is just like question number 6. It's a reverse process. Express 144 is a sum of the 12 odd numbers. So 144 we know it's a 12 square. It is mentioned also. Here it would be sum of 12 odd numbers. Now as it is a sum of 12 odd numbers, we need to add up the 12 odd numbers serially. 1, 3, then 5, then 7, 9, 11, 13, 15, 17, 19, 21, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is the last number, 23. So we have added 12 odd numbers to get 144. Question number 9. Express each of the following as the sum of two consecutive natural number. For doing this sum, we have a formula n square minus 1 by 2 plus n square plus 1 by 2. We have another method also, but we will follow this formula. It will be easier for you. N will be the given number. Thus, we will get the sum of the two odd numbers. We are given only one number. So, here it is 17 square. Let n is equal to 17. Then we can write 17 square as this one n square. N square, the formula I am writing, n square is equal to n square minus 1 by 2 plus n square plus 1 by 2. So, it is 17 square, n is 17 square. So, by 2 plus 17 square plus 1 by 2, 17. So, 17 square minus 1 by 2, 17 square plus 1 by 2. So, here it is 289 by 2 minus 1 plus 289 plus 1 by 2. Thus, 288 by 2, 290 by 2, get them cancelled. 144 plus 145. Here is the sum of the two numbers. Consecutive numbers. Consecutive means one after other. Here we have 144, here we are having 145. So, thus we can get the others also. Then question number 10, 11, these are all similar. I am doing question number 13. Write the Pythagorean triplets. Now, what is the Pythagorean triplets? Do you all know? If it is a right triangle, then this is called hypotenuse, this is called perpendicular, this is called base. These three sides are named as Pythagorean triplets because it follows the property h square is equal to p square plus b square. So, if it follows this property, then all the three sides are called Pythagorean triplets. Now, for using this, instead of h, p, b, we will take three sides as let the three Pythagorean triplets be twice m square minus 1 and m square plus 1. These are the three patterns, twice m to m square minus 1, m square plus 1. So, the given number have to be taken any one of them. It is said it is a smallest number. Somewhere if it is not, will not be mentioned, we will go on taking them. Let, we do not know which one is smallest. So, let any one of them we will take. Smallest is actually this one, but you may not be knowing, no? if it will not be mentioned, then what we do, if suppose I have taken m square minus 1 is equal to 16, then what it would be, 1 is shifted there, 17. But as it is a square number, to get only m, we need to take the square root of 17. So it is not an integer. If it will not be an integer, then those cannot be taken. So m square minus 1 cannot be taken. Like m square plus 1 also cannot be taken over here. If it is plus, then after shifting it will be minus. So it will be 15. Again, square root of odd number is not an integer. Therefore, obviously twice m, let twice m is equal to 16. Therefore, m is equal to 16 by 2. Thus, m equals to 8. Therefore, you find, therefore, the triplets are 1 is twice m itself, it is already given. Other is m square minus 1, so m is 8, 8 square minus 1, 64 minus 1, 63. Other one is m square plus 1, 8 square plus 1, 64 plus 1, 65. These are the three. Clear? One more question I am doing from this exercise. Question number 14. Very easy. Just you need to make the square of the numbers, like 2 square, 2 into 2, 9 square, 9 into 9. Thus finished. So most of the questions I have solved from both the exercises 11A and B. Now you try the lab sums, and other sums I'll do in my next videos. Till then, bye bye.